Hello guys, so today we're going to do relatively an easier chapter, limitations. Rather it is nothing much to explain, it's just definitions and points to note. So we start off with wing loading. What is wing loading? So wing loading is all up weight by area of lifting surface. Alright, next is power loading. Power loading is again all up weight by horsepower. Next is span loading. This is all up weight by wing span. Next is load factor, which is live load by dead load, which is also lift by weight. I mean, this chapter is going to be a little boring, I would just say, because it's just going to be definitions and how to remember all this. So wing loading, all of the above have all up weight, and wing loading is area of the wing, area of lifting surface, basically the wing. Power loading is horsepower. Span loading is the wingspan. The load factor is live load by dead load, or which is lift by weight. Now straight and level flight, we will have 1g force. Inverted flight, I guess you guys know, or you're guessing, it is minus 1g forces. And which instrument measures g forces? It's the accelerometer. Okay, it's in the options could be something to confuse you, g load measure or something of that sort, but it's accelerometer. All right, now there are different classes of load factor, limit load factor classes. These are classes: positive limit, negative limit. Just you can note it down, it may be asked in exam. Normal category, it is plus 2.5 to minus 1g, all are in g value, plus 2.5. Then next is utility category, this is plus 4.4g to minus 1.76g. Then there is aerobatic, which has the maximum range, plus 6g to minus 3g. So some aircraft which are aerobatic have these limitations. Okay, so it depends from your variant, time to time, whichever variant you're flying. So these are the categories. Alright, now I'm going to discuss something important in the limitations. These are the V speeds. Okay, so V speeds. So what are V speeds? So V speeds are certain speeds that are on the aircraft's indicated airspeed indicator, the airspeed ASI basically, which help the pilot judge various conditions. Okay, so I'll just draw a diagram so that it becomes very easy for you to remember the sequence of V speeds on a takeoff path. Okay, on a takeoff roll and takeoff path as well. So this is your runway, so I'm just gonna draw here. So 1 2 3 4 5 6 7 and 8. Okay, so this is the order that's going to be always for most of the aircraft. Alright, so VMCG, V1, VMBE, VMCA, VR, VS, VMU, VLO, V2. Okay, so these are the speeds you have to remember in this order only, and this will help you solve literally almost all the questions of the V speeds. If you remember this order, that's how it's easy gonna be. So VMCG, V1, VMB, VMCA, VR, VS, VMU, VLO. Alright, so now I'll write down few points that will help us understand. So V speed changes in accordance with aerodrome conditions, all up weight of the aircraft, I mean the takeoff weight rather, yeah, so the weight of the aircraft and the configuration. So the speeds will depend on this. Alright, so now what is affecting the aircraft performance? So the takeoff weight is affecting pressure, altitude, temperature. Now these will affect the aircraft performance. So you can just remember it like what? Weight, altitude, temperature. Alright, and the configuration, how does the configuration of the aircraft affect? So these are flap settings, slat settings, bleeds you're using, engine bleeds. This is jet aircraft concept, anti-ice and anti-skid if it is operable or not, anti-skid. So all these other configurations of the aircraft that can be used to improve the performance. Another last thing that affects is runway conditions, affect V speeds. So manufacturers have laid down tables and everything that decide say there's a wet runway, there's a dry runway, so how your V speeds are going to change based on that. So there's a slush on the runway, there's some dry ice or any of sort of the, conditions. So the runway conditions will affect the V speed. So you might have to rotate late, or higher V2 or higher V1 or whatever that sort. So these are the things that affect the V speeds. Now I'll just define some this video is going to be really short. It's not much of a discussion to be done. Now I'll define some V speeds. What are the V speeds? Okay, so if you remember the previous page I wrote, so let's start off with V1. So this is the takeoff decision speed. So this is the speed which dictates whether a malfunction during the takeoff roll will you reject or continue. So it's basically go or no go speed. So this is the speed where if a malfunction has occurred during the takeoff roll, you will reject or you will go. Okay, this is the speed below which. Then VR is simply the rotation speed, the takeoff rotation speed. So at this the pilot initiates rotation. Okay, next is V2. V2 is your minimum takeoff safety speed. So this is basically for the takeoff config. Say whatever flaps you're taking off, takeoff config, this will give you a speed 1 engine inoperative climb speed. Okay, so this is V2 is the minimum takeoff safety speed when your engine has failed. One engine has failed during the takeoff roll, or I mean just after you rotate, because if your engine fails just after you rotate, this is the minimum speed you have to maintain. So some aircrafts have V2 plus 10 that they maintain. So V2 is the absolute minimum speed that you have to maintain during a one engine failure on a takeoff path. Okay, so next is VMCG. So this is simple minimum control on ground speed. Okay, this is the minimum control on ground, MCG. So it is the minimum speed which provides directional control on the ground during one engine which is critical fails. Okay, Critical engine is the one which is closer to the fuselage. It's as simple as that. Do not get confused by the different terminology what critical engine is. So that is critical engine. Now there's something, I mean these speeds are just, there's no particular, these are just to understand how it is. So this is minimum control in air. Okay, so this is the same thing, control directional control in air, critical engine fails. Okay, it's the same thing, it's just this on the ground, this in the air. Alright, so next is VMU, minimum unstick speed. So this is like the minimum speed of the aircraft can lift off without demonstrating hazardous characteristics while continuing the takeoff. Alright, so this has the absolute minimum speed where when you just lift off, so there's no lateral instability that is induced or any sort of longitudinal pitch down or pitch thing. So this is the absolute minimum speed which helps you continue takeoff. So if you can see, VMU is at a very high margin, so it's a good value, so that you know even if you lift off here, the V rotate is here, when you rotate and the moment you lift off, so you will have a good smooth takeoff. There's no hazardous characteristics. Okay, next is our VLO. So VLO is lift off speed. So just as the speed at which the aircraft will lift off. Nothing much to explain on that. VMBE, Mike Bravo Echo. So this is maximum brake energy speed. Okay, so this is the maximum speed an aircraft can initiate a reject takeoff and remain within the heat limitations of the braking system. Earlier I told you that V1 is the takeoff's decision, where you go or no go. So if you can see, V1 is here, VMBE. So you can reject at VMBE, but that is the absolute maximum when you can reject. V1 is the one that the decision is generally made, but in case of some circumstances, special circumstances where you have decided that you cannot take off, so VMBE is the absolute limiting speed at which you can initiate a reject with remaining in the heat limitations of the braking system, maximum brake energy speed. Okay, so now I'm just gonna note down, write down some relations which is most helpful in the examinations point of view. Alright, so just remember, note this down, this will help you for sure. So V1 is always greater than VMCG, always less than MBE, and always less than or equal to VR. VR is always greater than equal to V1, okay, or less than greater than equal to VMCA. VLO must be always greater than VR, greater than VMCA, greater than VS, greater than VMU. V2 must be always greater than VMCA, VS, VR. Now that's the reason. Now if you have a problem remembering all of this, that's what I mentioned, so that you can use this diagram right here. So just for instance, just take over, say this one, V2 is greater than VMCA, VS, VR. V2 is greater than VMCA, VR, VS. Okay, VLO, that is here, is greater than VR, greater than VMCA, greater than VS, greater than VMU. So if you just remember this pattern, you can answer almost any question. So this is a very helpful diagram. Alright, so even you can just check for VR, greater than V1, greater than VMCA. So these are absolute relations that have to be maintained at any cost. Alright, so that's all for limitations. Actually it was a easy chapter to basically remember and note down. It's just more of a theory actually. So I'll see you guys with the propellers in the next one, and that's going to end subsonic aerodynamics for us. So that's all from my end. If you like it, do share it, comment for any queries, doubts, and suggest it to all your friends.
Goodbye guys.